Today we start our course in artificial intelligence. It's not our course, it's the course from Open Data Science community, but we asked the representatives of this community whether we can modify or add some information to this course, and they said, yes, you can do all what you want. So today we start with a Python programming language lesson, and then we continue to Pandas library, which is essential to data science. So every lecture starts with news, and today our news presenter is Anton. So basic rules of our club are raise your left hand if you have any question, and we will pay some attention to you and answer. And there is one more rule, which is you can ask what you want about data science and actually in general. And we will try to answer, because we established this club to help other people and help ourselves to learn this field of science, data science. And we're just happy to just learn something together. Okay, so we can move to the news section.
So hi everyone. You might wonder why do we have a news section. You might see a lot of news in the media about machine learning, about data science, and about recent advances. And here we talk about something that is new, but it's not necessarily connected to the course that we will have. So it's just a glimpse of what is currently in trend in data science. And this week we have a new version of PyTorch. It's a very well-known library for deep learning. It's frequently used for research because it allows you to prototype models very quickly. And now they are production ready. If you have a research-grade model and you want to convert it somehow into production, it can be easily done using torch.jit. It's a special just-in-time compiler for neural networks, which allows you to compress your neural network code into efficient structure. And it also allows you to use it in C++ very easily using a special API. You can see these links on the slide, and I'll share the slide later. Another great, that's how it looks actually in C++, if you are familiar with it. It's very, it looks like, just like Python almost. If you are used to PyTorch, there is the similar code for loading the model. You just pass the path to the file with the pickled model, and it just deserializes it. It might be hard for just first look on something that's done in data science just for a moment, but we'll come to the basics after the news. Another great example of something that is built on top of PyTorch 1.0 is fast.ai. We actually covered fast.ai before, some weeks before. The guy came from Ekaterinburg and actually gave a talk, but in Russian, about this library. It has some state-of-the-art models in deep learning, and it also has some cool tricks to get your model to converge faster. So please take a look. And actually, if you're eager to learn deep learning right away, you can do that using course.fastai.ai. It's a course built on top of this library by a very well-known specialist called Jeremy Howard. So here's that. If you want to ask a question, please just raise your left hand, and that will cover it. And something a bit not so recent actually, but it's resurfaced on the Hacker News channels, which I follow. It's actually a blog post about racist AI. What does it mean, racist? Well, in this post, the author actually analyzes sentiment analysis. So it's a field of study where you actually determine whether the sentence that is passed to some classifier is actually positive or negative. So in this blog post, the author checks if some sentiments of sentences containing Arab names, like black names and white people names, are actually different in some distribution. And he checks, and using some standard word embeddings, it's actually true, because in the language it tends to be like that. But then he checks for some other model which actually fixes this bias, and it kind of works, but not so well. And if you're really interested into this field, there's actually a recent article on the site theguardian.pub, which actually discusses some ways to get models to not have this kind of bias. And if you have some ideas in this field, we will cover that in the January. So we will not talk about the neural networks in this course, this semester, but in January we will return and cover them. So do you have any questions or some themes for discussion? All right, then we'll...
I have a question.
All right.
We won't have neural networks during the half of the course?
Yes, first half of the course doesn't have any of the neural networks. It has some of the parts which can be used in neural networks, like on the last layers of the neural network, but the construction of the neural networks is not part of the course. There's a lot more interesting things, but not some of that.
We probably will have some time to cover the basics of neural networks, but in order to understand, in order for you to understand the neural networks, we should cover some more material first. Just you should. I guess you'll just see the syllabus and understand what we are talking about.
All right, then to your part.
Do we have the part about the Kaggle?
About the Kaggle, I think it will be after the lecture. We actually had a Kaggle competition for the last 3 weeks, and we have a winner today, and he will give the talk about his solution, but it will be after the lecture. Take the cable.
Mm-hmm. Okay, we have some problem. Wait 1 second. So, today our topic is introduction to programming actually. So, do you know Python language? How many of you? We use it in data science every day, and it is really necessary to learn this programming language in order to understand what we are going to show you today and the next week and the next one. So I wanted to say we primarily use Python programming language, but actually we just do not use any other languages at all here. So if you want to advance in the data science field, you probably should just learn Python. It is really necessary. And today I'm going to cover the basics of Python programming language. Firstly, how many of you do know what is a Jupyter notebook. Okay, how many do not? So, it is an environment in which you can write down the code in any programming language like Python or Java, for example, for those of you who know it. And also you can write down some text, you can edit it, you can use markdown language to show some bold or italic or headings, as you can see on the top of this section. I actually have some technical problems right now, so I don't have this repository on my laptop, and I'm going to use GitHub, which is a service to host code or just text. I will use GitHub for now to show you the Jupyter notebook and our lesson. So everything I'm going to say today is hosted on our repository on GitHub, so you can just visit it. The link is in the message earlier, in the announcement of our lesson today. So you can insert formulas here in Jupyter Notebook. You can insert images like this one. It says believe in yourself and you could do the impossible. So this is what data science is about. So about the Python programming language. One more question. Is there someone who doesn't have any experience in programming? Okay, so you probably have a hard time here, but I'm pretty sure if you put a lot of pressure on yourself and take a lot of time studying, you can learn something, because the material is all here. All the lessons are on our repository. So let's just continue with Python. You can print some text, and where is our code? Where our code is located right now? It is in a cell. So cell is a basic unit of Jupyter Notebook. You can write down some code in any programming language. Here it is Python, and you can write some text, and actually that's all. You can write down some code and execute it. So you just press Shift Enter and the code is executed. You can use some functions from Python programming language. For example, print prints some text on the screen. You can format the strings which you put into this function. So you write these brackets, curly brackets, write down format, some expression, it gets calculated, inserted into the string and printed. One more interesting thing in Jupyter Notebook cells is that the last sentence in the cell gets outputted on the screen. So we used print function here 2 times, and we have these 2 lines. And the last line is also on the screen. I have to say that Jupyter Notebook is not a real, is not really good for development, for software development, because it is useful to just make some exploratory data analysis, which we actually do all the time in data science. And it is useful to show off some results, some pretty images like this one, and so on. So if you want to create a huge, complex program, you should just use PyCharm or something like that. We have hotkeys in Jupyter Notebook. For example, you have auto-completion here using tab, like in almost any environment. You can save the current state of the notebook. You can execute cells by pressing Shift Enter or Alt Enter or Control Enter. And actually there is a help hotkey which I did not use, I think, at all, which is Escape H. What can we do in Jupyter Notebook? We can execute code and we can show some images using libraries in Python programming language. One of the most important libraries is matplotlib. It is pretty complex and you should take some time to learn it, and it is hard to learn and hard to master. Not like when you say about chess, chess is easy to learn but hard to master, so matplotlib is hard both to learn and to master. But if you learn how to use it, you can show some pretty plots on the screen, and it is actually, it is really useful to learn how to present your results, because when you explore the data, when you build some models, some machine learning models, you should also get some value out of these models. And one of the ways to show this value is to present it on the screen, not in a text form, but using some nice plots, some nice pictures. More things about Jupyter Notebook. So we have magic commands here. It's not a part of Python programming language. You can use magic commands by putting a % symbol at the start of the line and then writing the command itself. So some useful commands are time and timeIt, which can show you how much time does it take to execute this line or this cell. Sometimes it's really useful to just understand, to profile your code, but it's not a really good way to profile the code, but there are some profilers in Jupyter Notebook. You can install them and just check where are the bottlenecks of your code. But actually in data science we don't really do it, because we just write the code, build some models and deploy them into production. We don't really care about the speed of the execution. Also, if you're familiar with Linux, with shell, you can run some commands from the terminal, from the shell of Linux or Windows, if you have one. So I'm going to say that if you have Windows, you're probably going to suffer on this course. Not very much, because almost all of the necessary libraries are ported to Windows and work well, but some of the libraries, especially the ones with neural networks, they do not work very well every time you use them. But there is some progress being made on porting these libraries to Windows completely, so probably maybe when we come to neural networks, you'll have the ability to use these libraries on your computer if you have Windows, and you will probably not suffer, just you will probably just have some inconveniences. So what do we do here? We have a command called curl. You paste some URL after this Linux command. You put an exclamation mark which we call bank, you put an exclamation mark at the start of the sentence, and this command gets executed. So CURL just downloads a web page and outputs it here. So why does it just output it here? I said earlier that the last line gets outputted on the screen, the last line in the cell. And here this line is not only the first one, but the last one as well. Do you have any questions, or maybe you just do not understand me at all? Okay.
I installed Anaconda. How can I launch
Jupyter. So I probably should have said it earlier, but you can install Anaconda software, and it will just contain all the libraries you'll need till the end of this course. And if you so Anaconda is huge, it contains a lot of libraries, and there is a simpler version which is called Miniconda, and also you can just install Jupyter Notebook and all the libraries you need using Conda, which is just the installer software. So if you want, if you have Anaconda and want to launch Jupyter Notebook, you should open your terminal. Do you have Windows or Linux? Okay, can you please help?
Yeah.
So I said there might be some problems. Yes?
I did not understand if the last line gets outputted or the result of execution of the last line.
The result of execution of the last line. So if you put some text into this line, it just gets outputted. Okay, so we have to wait for actually a lot of time here until it downloads, because the internet connection here is not very good. But I can show some examples. Okay, I should just find the seminars. Okay, I'll just show you a Russian version of this notebook. So we have a cell here. It has Is it visible? So you have several lines, you have print, another print, just text, a string, and another string. So if I execute it, these two lines get outputted because there is a print statement here and here. This line is on the screen here because it is the last one. So, and this line is lost. If I put a print statement, it gets outputted. The result of execution of this statement gets outputted on the screen. If I put another statement here, like just a string hello, it gets lost. So I can put it here at the end of this cell and it gets outputted as well, because there is no execution, it's just a string and it gets outputted. Okay. More questions? One more example is figures or plots or just images, to put it simple. We use matplotlib library to present some images on the screen. And here we use one more library, which is NumPy, which stands for numerical Python. So we use this library NumPy to quickly calculate some expressions, and it allows us to, for example, to calculate matrix multiplications really fast. Here we use it to generate a matrix which contains some random numbers, and we re-output it on the screen. This library, matplotlib, is really capable of a lot of things. For example, it can not only show two-dimensional images, it can show you three-dimensional plots as well. We will cover this library later in our course. So let's continue. Yes?
Why do you use underscore between and then equal using hardcode?
Why do we use underscore?
Underscore for the purpose.
Hmm?
What is the purpose of using equality in this?
It's just a way to show you that we can just omit the result of execution of some statements. So it is really useful if we have. I hope those of you who do not know the Python programming language yet will put a lot of effort and time into learning this language, because we don't really have time to learn it with you, to teach you this language. It's not like that, so I'm happy to answer all of your questions, but and I'm happy to send you some links where you can learn this language in more details. So this is why we are here, to share our knowledge. But Python programming language is huge. It looks really simple, but it can be complex. And there are some details which I can show it on the screen, and I can say why do we need it, but you will probably not encounter it too many times in the future. So this, why do I say all this? Because we don't really need underscore when we program. It is used to just omit or suppress the result of execution of some code. So functions return some stuff. For example, this function s returns 3 values, and we can say a underscore b equals s, and a is equal to 3, and b is equal a is equal to 1, and b is equal to 3. So we just suppressed the output of this function, one of the values. So this is an example of unpacking of a tuple. Okay, so I probably should stop diving into the Python, but I guess I have some time to say that we have several data types in Python programming language, and some of them are iterable. So you have some values and you can iterate over these values. And one of the greatest probably things about Python is that you can return multiple values from the function. So you can return 3 values or 5 or 2. And when you do it, you can use unpacking. So we have a tuple as a result of this function. And a tuple is a container which is immutable. So we can't change the values here. So we can't just say that this number needs to become 3. I can just show it. So there is a type error because tuple object is immutable and it does not support assignment. And this is the way to return several values from the function in Python programming language. And we can use unpacking to unpack this tuple into several values. And the amount of variables here should be equal to the length of this tuple. So there are 3 elements in this tuple, so I put 3 variables here. And if I put 2 variables, there is a value error because we have too many values to unpack. We have 3 values to return from this tuple and put it into the corresponding variables, and we have only 2 variables. So it's like we have 3 apples and 2 people, and we cannot just give more than 1 apple to a person. I'm not sure if it's clear or not, so raise your hand if it's not clear. I won't be offended. So, in the future, do not hesitate to ask any questions. We have me and 2, teaching assistants here. So it's Anton, which can help you, and Vlad. Please raise your hand. So if you have any questions about the programming or about data science, you can just ask us. So, a bit more about this programming language. We learned about the environment, which is Jupyter Notebook, and now we can dive into the Python itself. So, Python is very popular, and the main reason for this is Python is pretty simple. So, you can just write down some pseudo code, and it will. You can just write some text and some imperative text. So you just say, it's not a notebook. You say a equals to 1, and you've just created a variable which is called a, and there is a value 1 in this variable. So it's a pretty simple and nicely looking language. It has a philosophy, and there is a lot of lines here in this philosophy. Not actually a lot of lines, but I will probably read only the first and the second line because they are really important. The first one is beautiful is better than ugly, so we want to write beautiful code. In data science and in software development as well, in general, you probably write ugly code most of the time, and then you just refactor it into something good, probably. But this language allows you to write beautiful code, and this code looks really simple, and it can do a lot of crazy and powerful things. we'll see in the future how easy to write programs in this language. And the second one is, the second line in the philosophy of Python is explicit is better than implicit, which means you should write down your intentions explicitly while writing the code. It's really good because if you write some code which is not easy to read, it will be hard for you to understand what you wrote, for example, 2 days later. It happens all the time. We have several standard data types in Python programming language. For example, numbers. Pretty easy, right? Just some integer number, some float number. We have complex numbers here as well, but we use J instead of I in this language. We have special types, decimal and fraction, which we will probably not use in this course and maybe at all. But it's good to know that this language contains a lot of useful data structures, except some of these data structures are useful in very limited scenarios. Most of the time we will just use integer and float values. So we have strings, just some lines of text. We have multi-line strings. We use this construction to write a string which contains several lines. So we put 3 apostrophes at the start and at the end. And we have a line. It does not look like a multi-line string, but we did not print it. If we print it, we will see what was intended. Do you have any questions? Am I moving too fast or too slow? Okay. So we have lists. It's not like I'm going to speak quicker, but I probably will. I will probably just omit some stuff here. So we have lists, which list is a collection of some objects, and it's not an array. In some other programming languages, arrays can contain only one data type inside. So every object in the array should be of one type. So like an array of strings, array of integers. Here in Python you can put any object into the list. Dictionary. It is a collection which has keys and values. So keys are unique, values are not. You can get values from the dictionary if you know the key. I guess it's pretty easy for you, right? Tuples, as I said earlier, tuples are just like lists but immutable, so you can't change the items inside tuples. Sets are a bit like lists, but we do not know the order of objects inside the set, and also we do not have any copies, so all the elements are unique in the set. Also we have files, so we can just open a file and read its contents in Python programming language, and it's pretty easy. Python is a dynamic language, so we do not say that this variable will be integer or string. We just put a value inside the variable and the variable will know its type. We have different types of numbers, but I don't really want to spend a lot of time on this. So main number types are integer and float. So let's continue. We have all the necessary operations like sum and multiplications and so on. And we have several others like the power. So we can put this number 3 to the power of 2 and get 9 using 2 stars. We have some capabilities, some mathematics capabilities in Python, but we will not probably use these functions a lot because in the future we will use the NumPy library, which will make all of these operations happen a lot faster. Some real numbers, fractional numbers, strings. We can concatenate strings, so we can just write down some text, write plus and another example of text, and we will just make a summation of these strings. So Python does allow it. We also have some functions which will just ease our life a bit. For example, if you have spaces at the start and at the end of the string, we can use strip to delete these spaces. We also can replace words in a string. So we bought a new house turns into we bought a new building using a replace function. One of the more common functions with strings is split, which splits a string by some divisor or divider. So here we put a space and we get a list containing all the words. So in the original string there are spaces between the words, and now we have a list of these words. And it looks simple, but it is really sometimes it can be really useful when you work with some paths, when you want to process some data which is located on your hard drive, for example. But there are some libraries which will help you to do that as well. So we have a boolean or bool or logical variables here. It's just true and false, yes and no, 1, 0. It's simple. We have several operations like and, not, or we just write it using English language. We have operations like greater, greater or equal, and so on. Okay, so loops allow us to execute some code several types. I assure you, the next material on probably, which we will cover probably in half an hour, will be much more interesting than this, but I have to make sure that all of you at least can just understand what I will be talking about next. So we have 2 loops, while and for, and these loops allow us to iterate over some collections. For example, if you use for loop, you can just write down for some x in collection, do something with this object x. But loops in Python are a bit slow, and this language is slow in general. So if you want to write some high performance applications, you should probably just use C++ or something else. However, if you want to speed up your calculations, but you do not want to leave this language, you can use, as I said, NumPy library, which we will cover probably next week. Okay. So data structures, as I said, list, set, dictionary, tuple. Do you have any questions about these data structures? If you have, please just raise your hand and I will quickly explain it to you. Okay, so what is the question?
There is an example on odd squares.
Okay, so it is a really good question, because this construction is called list comprehension. It allows us to write down some loops in just one line of code, and it can be really useful. For example, you have numbers list, which is some numbers like 1, 4, 2, and so on, as you can see on the screen. And using this list comprehension, you can get a number from this list and apply the function of power to this number if it is odd. So
I take from the list only odd numbers and then square.
yeah, and list comprehension is really powerful because it allows you to write down a lot of code in just one line. But you should be really careful, because you can write really ugly code using this list comprehension technique. I did it all the time in the past, but now I'm cured. Okay, so let's continue. More questions about data structures, because we will probably not cover it later. Functions. Functions are just some blocks of code. You can write a function, so you can write some code, give it a name. You can tell the function what variables should it expect, and you can set default values to these variables. After the execution of the code inside the function, you can return the output, and as I said earlier, you can return multiple values using tuples. So you just put commas after each value. For example, if I wanted to return A, B, and C, 3 values, I would have put commas instead of pluses here, and I would have returned 3 values. You can use this. It's not an operator. This. Okay, let's say that. Okay, you can use this. It says pass. You can use it as a stub. So it just sits here and does nothing. So this function is called do something, but actually it does not do anything. This is a panda because the library is called Pandas. What will we do today? Now we will start some actual data science. We will look at the data, and this section will be harder than the last one, because now we will see some methods which we use on a daily basis when exploring data. So imagine you've got some data set. It consists of some examples. For example, a data set of people. You have 100 examples. Each example is a person which has some features. Features might be for example, there are some features like age and hair color and so on. I just don't have any imagination today. And you want to get some insights from this data. You want to learn something interesting. And this library, Pandas, allows you to really quickly understand some interesting things from the data. For example, it allows you to just look at the data with your eyes and apply some functions to extract, for example, an average value of some feature, like an average age of the people in this data set. We can read several types of files using this library. For example, CSV, which is comma separated values separated by comma, which is pretty obvious. We can read Excel files. We can just read some text files and so on. Most of the time we read CSV files, and sometimes we read Excel files, which are just spreadsheets like this one. And I guess that's all. So imagine we have a data set about churn rate of the clients of some telecom operator. Churn rate is a number from 0 to 1 or from 0 to 100. It is a percentage of people who leave the operator. For example, you bought a phone, you went to a store to get a SIM card, and then you used it several times and threw it off. So you just contributed to this number, the churn rate. And it is an important task in the field of data science to predict the churn rate, because it is much easier to help client to stay with you than to attract new clients. Companies just lose money when clients leave. It's pretty simple. And we're going to talk about business here sometimes, because we should generate some value. Do not just look at the data, get some insights from it and go to bed, for example, and sleep. We get these insights to pass it to some people who understand what to do with these values, with this new information. Okay, so let's return to Pandas. We can use one important thing for people who do not know the Python language yet. we have modules in this language. So modules are just folders with Python files, with some code. And you can import these modules. And these libraries are modules as well. These modules just contain folders which contain some files. And these files contain some functions, and we use these functions. So we use import statement here to import this module to get some access to the insights of this module. And we can use alias, which is another name to this module. We can write here anything we want. So usual alias for NumPy, for example, is np. Usually we use pd for Pandas. And this is just an agreement. You can write anything you want. But if you want for other people to understand your code to be able to read it quickly and understand what it says, you should probably use the same agreement. So here we use Pandas library. So we write pd and dot. We write dot to access the functions inside this library. And one of the functions is read CSV. We write the path to the file which contains our data set, and we use head function which outputs the first 5 lines in this file. So we have a lot of things here. So lines are examples. As I said earlier, if we have a data set about people, every line will be a person. Here it is the same. So we have a data set about the churn rate, and every line here is a person. And every column here is a feature. For example, this first person today, this evening, it's total. So during the amount of time this client used his or her phone, they made 99 calls in the evenings. So it's an example. It is an example of a feature. Another example is it is much simpler. It is a state. For example, this is probably Ohio and New Jersey and so on. And other features might be even more simple, like age, sex, location, date of birth, and so on. Do you have any questions? So this table, it has a shape. So if we write df.shape, we will see several numbers. Here we will see 2 numbers. The first one is number of rows, so number of examples in this dataset. And the second one is number of columns. So it is a number of features in this dataset. So we have about 3,000 rows, 3,000 examples, and 20 columns, so 20 features. And how to look at the columns is pretty simple. We write df.columns. And on the screen, you can probably see the names of these features. If you want, you can download this notebook, or you can just look at it online, right, like I do right now. Or you can see, or you can probably see the text on the screen. Can you see it from up there? Because I can't see it from here, so I'm a bit worried. We can extract some basic information from this table, and I forgot to say an important thing, which is how do we call this table in Pandas library. It is called data frame. It is a data structure like list or dictionary, which we discussed about 20 minutes ago, but it is much more complex. So it says here we have 3,333 values, and these are the columns. It says non-null and the type of this column. So it's bool, logical values, int, float, and object. Usually, if you see an object here, it is a string, so it is some text. And other types, I hope they are self-explanatory. So int is integer value, float is float value. So just some numbers. And it says the same number here as the amount of examples in the data set, and it says non-null. So what does it mean? Sometimes we have missing values in. We always have missing values in our data. And we need to deal with these missing values somehow. We will, for example, we might have an age feature here in this data set, and for some people there might be just no value at all. So a person just decided not to tell his or her age. This is just one of the examples, and missing values happen all the time, and they ruin the execution of machine learning algorithms. So you're just obliged to somehow deal with these missing values. This is toy data set, so it was made specifically to just use it as an example for all of this stuff I'm going to talk about. So let's just continue, and we'll deal with missing values when we get to them. We can change the type of a feature. So we have a feature churn. Firstly, I think it was bool, so it contained true and false values. And then we said we got this feature, which is called churn, by writing down these brackets and putting the name of the feature inside them to get this column. So from the whole data set we can get one or maybe a set of columns and apply some functions to them. And this is an example of this set of functions as type. So we can turn all the values inside the column to some other type, which we can put its name here. So it was logical values, true and false, and we turned it into integer values. So true in integer means 1 and false is 0. Should I go faster, or is it okay? So there are people who not the first question and the second. Raise your hand if you if it is okay to tell at this speed. Okay. I guess you understood me. So one more method is describe. It returns a data frame, a table, and every column is a feature from the original data frame, and every row is some statistic from this data set. For example, count is just the number of values in this feature. So it is the same, because we don't have any missing values. Next, mean. It is an average number in each of these features. For example, if we had column which a column called 100 and it contained only the number 100, an average, the mean value would be 100. We have some more statistics like standard deviation, minimum, mean, max. We have quartiles. So we have, okay, I guess it's not the time to explain statistics right now. We'll probably have another lesson specifically for this topic. So let's continue. We can use describe to include only features with specific type. It's just an example of what you can do with Pandas library. I urge you to look at this Jupyter notebook later after the class, and if you do not understand something, you can just Google, or you can ask a question in our chat, and there is almost 500 people. There is always someone who can help you. Let's continue. So one more important function is value counts, which just returns one column, and the values here are the amounts of corresponding values in the original column. So in the column churn you have about 3000 zeros and about 500 ones. So out of 3,500 people, 500 people left. This function allows us to normalize its values, which means to divide each of these numbers to the sum of these numbers. So we can get a percentage. So 14% of all the people in this dataset left this operator, which is not very good for this operator. We can sort values. It is pretty simple. We just write this data frame, this table. We write its name, write sort values. It's not like in some more complex languages like Java or C++, but you just write sort. You write ascending false or true to control the order. And you write the column by which you should sort. And it is really simple to sort by multiple columns. You just write these columns in a list, the names of these columns in a list, and you can write, you can specify the order in which you should sort the values corresponding to these columns by which you sort your data frame. It's really useful to get, for example, top 5 total day charts, so people who spend a lot of money. So you can just, and if you sort by churn and ascending is true, these people, zeros will be at first, so because it is ascending, so zeros first, then ones, and top 5 people who spent a lot of money but left. It is an interesting way to just look at the data without any machine learning models. You can get some insights from this, probably. One more example of functions. As I said, these data frames, these columns have a lot of useful functions, like, for example, mean, which will show you an average of the values in the column. And we can retrieve information using some conditions. For example, here we write the name of our table, write brackets, and inside the brackets we put a condition. So we write only values where churn is equal to 1. So we get only clients who did not left the operator. And then we have a data frame only with clients who did not left. And then we count the mean. So here mean of the churn is 1 because all the clients are still with the operator. And we can say that, for example, mean amount, average amount of night calls is 100, for example, for this type of clients. It is really useful because you can just give it a glance and understand which types of clients have some interesting features. I guess it's not really easy to get some insights from this data, but if you're an analyst working for an operator, you can probably understand what these values actually mean. And in the data science field, you always have to dive into the field in which you're working right now. So data science is everywhere right now, and you can apply it to different topics like physics or finance and so on. And these fields of science are completely different. I guess one thing in common is that they all use mathematics right now, but they have different types of experience, different types of data sets. Some data sets consist only of text or of images, but the methods of data science, they can be applicable in different situations. And as a data scientist, you should try to understand this field you're working on right now. So if you're creating a data science project in the field of chemistry, you should know what the valence is, for example, or what types of elements exist, and so on. There are several questions here. I hope you can see them. So, for example, how much time on average do churned users spend on phone during daytime? And this is just a question, so some person not connected to programming at all but who is your boss, for example, can visit you someday and ask this question. It's just plain and simple English. And you can turn this request into a code using Pandas. It looks really simple. So churned users, so users who left. We just perform the same operation as before. So we get users who left. Then, how much time they spent on phone during daytime. We have feature called total day minutes, and on average we just use mean function, and we get the result. Do you have any questions about this line or in general about Pandas so far? Raise your hand if it looks hard, complicated. This line and everything before. The next line looks a bit more complicated. So, what is the maximum length of international calls among loyal users? So, loyal users are users who are still with the operator, whose churn is equal to 0. So, who do not have an international plan. I said earlier that some features have type object, and it means that the values are just strings. This is an example. Feature called international plan contains some strings. I guess it's just no and yes. So we can use logical conditions here as well. But instead of and, like I showed you before in the previous section, we should use a special symbol ampersand, and this stands for and. And if you want to write or, you should use vertical line. I don't know how to name it in English. So it's just this line. Pipe? Oh, okay, it's pipe, yes. I guess you use Linux. So, knowing all this information, it looks pretty simple. We just get clients with churn equal to 0. We get clients who do not have an international plan. We use AND here because we want to get clients who both loyal and do not have an international plan. After that, we put this whole big condition into these brackets to get this filtered data set. And then we get total international minutes and calculate maximum length, which is 19 minutes. So I guess it's pretty expensive to not have an international plan and talk for 20 minutes. And this is what all of this is about. Okay, we still have time. So we can index these tables, these data frames, by column names or by index. So here index is just a number, a list of numbers from 0 to 3,000 something. This index may contain different type of values, for example, strings, like names. So this index may contain names of these people, and they should be unique. However, I'm not sure if Pandas will crash or throw you an error if you put non-unique values here, but I guess you just should not do it. So you can also index this table by the index of by a serial number of the value you want to get, or you can get a number of values span by putting a colon here. So if you want, so you see comma here, so comma is needed to get to index both by row and by column in the table. So first values here are rows, second are columns, and 0 colon 5 says get me these values from the table which have index from 0 to 5, which have numbers of rows from 0 to 5, and give me the columns and give me values whose columns are from state to area code, including both feature names. So we have this data set which shows you the values we requested, and we used log statement here. There is one more example which is ilog. I'll tell you about it in a minute. So why do we need it? We need it to get some specific values. Often we needed to get a specific feature from a data set or a specific set of features, because here you can not only put a slice. Some of you probably do not know what a slice is. In Python programming language, it is a way to extract several values from a list, for example, from an iterable, from collection. So if you have 1, 2, 3, 4, you can get values, for example, 1 and 2, using a slice. So you can write down, okay. You can write something like this. So this is a list, and here we index this list, so we get values 1 and 2. Why did we get 1 and 2? These numbers are indices of these values here. So the value 1 has index 0, 1, 2, 3, and so on. And we get values from 0 to 2, not including 2. It's Python. Maybe there is a clever answer to this question, but I just don't know. This is how Python works. And this is just almost the same. So here we include the last value. So here we write area code, and it is included in the output. It is a bit inconsistent with Python, but we just have to deal with it. The next one is ilog. There is only one difference, at least as far as I know, which is we do not put names of features here after the comma. We put numbers which represent the index, like here. So if we want to get columns from 0 to 3, we put 0, 0, colon 3 here, and we get these columns. Okay, it's a bit strange. Somehow there is only 3 columns instead of 4, because slice from 0 to 3, including the last one, should output 4 columns. So maybe I'm just wrong somewhere, and it still did not download on my laptop, so I can't really show you what is the problem here. Okay. But the main idea is you can just get some parts of your table, some rectangles from the whole table, using this syntax. Any questions? We will use it all the time and you'll just get used to it. There is one more example, which is we can use negative indexing, which works the same in Python itself. So you have a list which contains 1, 2, 3, 4, and if you want to get the last value, for example, this list is called A. You can write A minus 1, and it will output 4. So it counts from the last value and goes to this side. So minus 2 will return 3. Okay. Can we continue to the next section, which is apply. Apply is an important function which says apply a function to this data frame. And here we write a function from NumPy library. I hope we will have some time to explore it, because it's really useful in a lot of applications. But here we just take max function and apply it to every column. So we want to get the maximum value of each of the feature. So the maximum amount of calls in the evenings is 170. I guess this information may be useful. We can apply more sophisticated functions to these columns if we put a different function here. So for example, we can write some arbitrary function, like write down here something. Okay, this function should accept a row or a column. There is a syntax which allows to switch between rows and columns if you use apply function. And we do something with row, some stuff, and then you return some value. Okay, so it's this function will not work because it says row return value. But you can just write any function you want and apply this function to a data frame to get what you want. For example, if you want to, okay, it's hard to come up with something interesting right now, but if you want, for example, to turn this value total night minutes to a bool value which says if you have more than 100 minutes it says true, and if you have less than 100 minutes, it says false. So you just turn it into a bool value. You can just write down a function which returns 1 if the value is more than 100 and 0 if the value is less than 100. And in this case, and save it in, for example, a new column which says, for example, like total night calls more than 100. And you can use this information later in your when you will build your own machine learning models, because these new features can be useful. Some models can build their own features, like, for example, neural networks, which is the reason why they're so powerful right now. But if you want to use simpler models, which do not require a lot of data, you should spend some time on feature engineering, which is a process when you just look at the data until you come up with some interesting feature. And you're not just looking at the data, so I can just stand here and stare at this table. You perform exploratory data analysis. You explore the data to understand it, to grasp it, and to know what features you might create from this data, and maybe from other sources, which will help the machine learning model to predict some value. For example, what can we do with this data? We can build a model which predicts whether a client will leave an operator or will not leave. And this feature, which I said, night calls more than 100, might be useful. And in the future, we will discuss some methods on how to understand which features are useful and which are not so useful. And if the feature is not useful, you can just throw it away. Most of the time. So here we use apply method as well. And we use it to a column state. We apply some function to a column state. We can use the function apply. We can apply this function not only to tables but to features, to columns as well. And sometimes it can be really useful. Here we use a lambda function. Raise your hand if you do not know what this means. So it is an anonymous function which does not have a name. You just write down lambda, you write the name of the input variable, which is state, you write colon, and write some function. Usually it is a simple function like this one. It is possible to write a complex function here, but it will just look ugly. And as you should remember and remind yourself every day, beautiful is better than ugly. One more interesting method is map. Map maps values. So it takes, for example, a column. It takes, in this case, a dictionary. However, it can take a function as well. And it looks at the values and changes them according to this dictionary. So I said earlier that international plan variable should probably have values no and yes. It had type object. and it says if you have an international plan, you have yes as a value corresponding to your example, to your row. And what we want to do, we want to turn this feature into a column with numbers. Why do we want that? Because all the algorithms work with numbers, and they usually do not accept text. So what we do here, we change every yes to true and every no to false. And these values, false and true, we can simply turn into numbers using S-type, as I said earlier. Questions? I guess I'll leave you a bit more homework than we expected. So the very last part of this Jupyter notebook, it will be up to you to read it and explore, but because it's really a lot of material here yet. But moving to the next topic. The next topic is grouping. So you can group some values by some columns, and you can apply some function to get some aggregated values from these grouped values. So maybe it sounds really complicated, but it's simple. You group by churn. So here you can see all the unique values inside the churn column. So it's 0 and 1. And you see values corresponding to, in the first row, corresponding to 0 to the churn equal to 0. And in the second row, values corresponding to the churn equal to 1. And then you decide which columns you want to output to the screen. So, for example, total day minutes, total evening minutes, and so on. And you put these columns into the brackets. And then you use some aggregation function. For example, you can put an averaging function, min, here. Here we use describe function, which outputs not only an average value but also count, standard deviation, and so on. So for every column which we wanted to show here, which we described, we see how many zeros we have corresponding to this feature, which is the average amount of total day minutes, for example, for people who did not left and for people who left the operator. So we can see that these values differ. So standard deviation, mean, max, and 50%, which is the median. We will look at the statistics later, I hope. And we can see that this technique is really useful when we want to describe our data and group it by different unique values inside the column. We can use here not only one function, but we can put a list of functions we want to apply to these grouped data sets, small data sets. For example, here we make a list of functions, and all of these functions are applied here to this grouped data. So we just see only the numbers we wanted to see. So we have some flexibility here. we also have some summary tables. I will spend some time just quickly talking about this topic, and I hope you will look into it more closely later. So one of the methods is cross-tab. It is a contingency table. You put two features here as arguments, and you see a table which says, for example, how many users you have who at the same time have churn equal to 0 and international plan equal to false, and so on. And you can normalize it like we did before in value counts, and you can see the percentages. So 60% of all the people in the dataset had churn equal to 0 and voicemail plan equal to false, and so on. One more method is pivot tables. We put several columns as a first argument inside the list, and one column as a second argument. And also we put some aggregation function as the last argument. And we see that columns here are the columns which we put here in the first place as a first argument. And rows are the unique values inside the feature which we put here as a second argument, area code. And the values here are average values for example here 100 and something. It is an average value for people who have area code equal to 408 for feature total day calls. So it is useful to just get an information, for example, about outliers. Outliers are values which just have some extremely high. So outliers are examples in the dataset which have extremely, for example, high values. So if you have a dataset of people, for example, and one of the people has a weight equal to 9,000, it is not possible. People just do not weigh this much. So it is an outlier. Probably some error or a joke. So you should just throw these values out of the dataset because it will make because of these values, because of outliers, the machine learning algorithms often fail to predict a correct value. Okay, so one more thing about data frames. You can use different arithmetic operations on the columns. For example, you can sum these columns and they will sum element-wise. So if you have two columns which are day calls and night calls, and they are equal to 1, for equal to some numbers. And if we want to sum these columns, we will get an element-wise sum. It might be useful when you're trying to create new features. Like here we have a variable, a feature total calls, which is day calls, night calls, evening, and international for some reason. So these are just some examples. And okay, this is the last part, which is called first attempt on predicting telecom churn, which is probably the hardest part of this Jupyter notebook, but I leave it to you as a homework. I guess it is not compulsory to read it, but if you want to learn more about this topic, about data science, about Pandas library, you should look into it and ask some questions if they arise. I guess that's all.
One more thing.
Okay.
So why did we start this course right now, in this week? Because there is an activity. If you want to get recognized that you passed this course, there is actually a way to do that. Just go to the GitHub page of the course, and here you'll have the link. You have been paying for GitHub, right? Anyway, so fill this form right here. Click on this link and then fill the information about yourself. For example, your email, the most important part, your last name, some introduction about yourself. This data is collected by Mail.ru, if I'm not mistaken. They're paying the guys who created this course, the first versions of this course. And then you can submit your assignments. Actually, they'll be out every week. This week's assignment is here. You can access here it by pressing NB Viewer. And the deadline is October 14. The deadline actually is at midnight in Moscow, between the October 14 and 15th. And I'll introduce you to the assignment. It's basically some data, some EDA, exploratory data analysis, where you have to count some statistics on the data set that is given, and then to submit the Google form, which will automatically grade you whether you can calculate the statistics correctly or not. If you have any questions on this assignment, you can actually ask them in chat, and well, we can help you in a way, but we'll review the task after the deadline. And now it's thank you for your attention for the lecture part of the today's meeting. And now we'll have some another activity. If you want to leave, that's okay. If you want to stay and learn how to actually apply the methods of machine learning, which we cover later or right now, you can stay. And Kostya, I invite you. Where are you? Come here.